Hello everybody, here is the second part of the advanced limits video. So in the first part of the video, we talked about these limit rules here, and we focused mainly on composite limits or compositions. So in this video, we're going to talk about sums, differences, and products. So I want to draw your attention to this property right here, because we're going to do this one and this one especially. We're going to do the product one first, which says if you have the limit of a product, it's the same as the product of two separate limits. So let's go ahead and try and apply that to one of these problems here. We're going to do number one. Now you already did this one for the previous video, so we're going to ignore that for now. So here's my f function, here's my g function. Normally what I'd be able to do is the limit as x approaches 1 of f times the limit as x approaches 1 of g. So let's go ahead and try it. The limit as x approaches 1 of f, oh, that does not exist, times the limit as x approaches 1 of g, okay, that does exist. So now I have 0 times does not exist. All right, 0 times does not exist, that doesn't work. You can't say, oh, well, the answer is does not exist. And other people might argue, well, that's 0, because 0 times anything is 0, but it doesn't really work when one of the limits does not exist. So if one of your limits is not defined, then the rule does not work. So what we're going to do instead is go back to one-sided limits again, and let's see what happens now. So we're going to do the limit as x approaches 1 from the left of f times g, and the limit as x approaches 1 from the right of f of x times g of x. Okay, so now let's try it. We're still going to do the type of property where we do the limit of f and then the limit of g, but we're only going to do it from one side. So the limit as x approaches 1 from the left of f of x is -1. The limit as x approaches 1 from the left of g of x is 0. That gives me 0. The limit as x approaches 1 from the right of f of x is 2, and the limit as x approaches 1 from the right of g is 0. In both cases, it's 0, so the overall limit is 0. So just be aware, if you are trying to apply these properties and one of the limits does not exist, you can't do those properties. You have to do one-sided limits, because again, this assumed that both limits exist. Okay, so that was a product. Let's try doing a sum. And I'm going to use, or try to use, this property right here, the sum one that says the limit of a sum is the sum of the limits. So let's go ahead and see what happens whenever we do that. That would be, let me write that out. Okay, so here's where I'm going to attempt to use the limit property. So the limit as x approaches 1 of f of x. Now notice they talked about f and then g, but in the graph it was given as g first, then f. AP will do that sometimes just to make sure you're actually looking at what you're doing and not just blindly trying to do math. The limit as I approach 1 of f of x. Okay, that doesn't exist. The limit as I approach 1 of g of x plus 2. Now this is g of x. There's two ways to think about it. One way is to think, okay, if I put 1 in, this really becomes g of 3, and at 3 I have a jump discontinuity, so I can't do a limit there. Both of those limits don't work, so you definitely can't apply this rule here. Another way to think about what g of x plus 2 really means, because this is actually a composite limit again. You have an inside and then an outside function. What g of x plus 2 means is I'm going to take my function g of x and I'm going to move it left 2 units. So here's another way to think about it. If you tried to do the limit as x approaches 1 of g of x plus 2, I went ahead and drew g of x plus 2. I just shifted everything to the left 2 units. Now if I do a limit as they approach 1, you can clearly see the jump discontinuity there. So this limit does not exist. I just don't want you to look at this and see, okay, the limit as x approaches 1 of g of x plus 2 is really g of 3, and g of 3 is 3. You don't want to think like that. You're still thinking limits. Okay, so I'm going to do one-sided limits here. So I have the limit as x approaches 1 of f of x, and I'm going to go from the left this time. So I'm still going to break up my limit into two different things and add them. So 1 from the left of f is 1, and then 1 from the left of g of x plus 2. You could do it two ways. You could think of this as g of 3 coming from the left, and look at the graph here, g of 3 from the left. That's definitely going to be 3, which is 4. Or you could look at what I actually graphed in red and find the limit as x approaches 1 from the left of what my red graph is. 1 from the left is still 3. Either way, it's 4. All right, now let's try this. Limit as x approaches 1 from the right of my function f. This time is 2. Limit as x approaches 1 from the right of g of x plus 2. That's kind of like g of 3 from the right. So here's g, here's 3. G of 3 coming from the right side is 2. Or if you want to think the limit as x approaches 1 from the right of the function g of x plus 2. In red, remember, was g of x plus 2. Coming from the right towards 1, either way, I get 2. So the limit from the left equals the limit from the right, so this sum is 4. Again, the way you want to think of this is not as a separate limit of f and a separate limit of g. This is its own new function. We could call it h of x. The sum of f of x and my red graph, g of x plus 2, would create a new function h, and I'm really finding the limit as x approaches 1 of that. So you always want to think like you're using these two graphs, but this is really its own entire function. To end, here is the actual question that was on the AP exam in 2017. The first time I saw this, I was like, whoa, because I had never seen where they do like a product of a limit and it's not completely obvious what it would be. So here they have not only a composition and a composition, but then they also have this product here. So take a look at this and let's see what you think it is, and we can talk about it whenever we are together again. See you later.